Determining the number of atoms of each element in a chemical formula. Today, you can achieve 70% or higher on your exam. Your starter reads true or false. You'll drag and drop on your copy. A molecule of sorbitol contains 3 more oxygen atoms than a molecule of glutamine. So let's go up here to our chart, find sorbitol and glutamine, and compare oxygen atoms. In sorbitol, you have a subscript of 6. So you have 6 atoms of oxygen here. And then going up to glutamine, here you have a subscript of 3, indicating you have 3 oxygen atoms of glutamine. So yes, sorbitol contains 3 more oxygen atoms than glutamine. So we could write true for that question. What might throw you off here is the word molecule. So here in front of these chemical formulas, you're looking at one molecule. Okay, there is no coefficient written in front of this chemical formula, so you just assume it's just one molecule, that one that you're looking at. Let's go to our second question. It says, a molecule of lactose contains twice as many atoms as a molecule of fructose. So we're comparing lactose and fructose. Okay, so usually you could write these side by side. You can write out your element and how many it has. So lactose has 12, and then fructose has 6 carbon atoms. Okay, so far that's twice as many, that's double. Okay, let's compare our hydrogens now. If you look at lactose, you have, for your hydrogens, you have 22. And if we compare our hydrogen atoms with fructose, you have 12. Okay, so we can see that that is not double. Okay, because 12 plus 12 is 24, so right away we do not have double the amount of hydrogen atoms. So we could just say that's false. And we can go a little further and compare our oxygen atoms, and that's not double as well, because you have 6 here and then 11 here. If lactose had 12, then yes, you could say you had double the amount of oxygens. All right, for a summary, we're going to use the chemical formula above to write a summary on how to count atoms in chemical formulas. So I will have a discussion on how to count atoms, and then you can type your discussion, your summary here. So looking at this chemical formula, the first thing you want to do is look for capital letters. Every capital letter signifies an element. So here we have a capital F and a lowercase after it. So we have iron. We're looking at another capital letter, so we understand that's the element sulfur. And then another capital letter, so we have an oxygen atom here. So we have 3 different elements involved in this chemical formula. In order to count the atoms of each element, you have to look at subscripts. So a subscript is that small number to the right of the element, indicating how many atoms it has. So iron has 2 atoms. Coming over here where we have parentheses, what you need to do is take the subscript outside the parentheses and multiply it by the subscripts inside the parentheses. If there is no subscript written after the symbol to the right, you would assume it is 1 atom. either that one element you're looking at, or you could write an imaginary one. So 3 times 1 would give us 3 sulfur atoms. Then you would do the same for oxygen. You take that subscript outside the parentheses and multiply it by the subscript inside. So 3 times 3 is 9. I'd have 9 oxygen atoms. The subscript after the parentheses only applies to subscripts inside the parentheses. It has nothing to do with your iron atom. And one other thing we could talk about, if there was a number in front of this compound, like the number 2, we would say there are 2 molecules of iron sulfate. Since iron sulfate does not have a coefficient in front of the chemical formula, we assume it's just 1 molecule. That 1 molecule we are looking at. Your formative assessment is on 8.5D, recognizing chemical formulas are used to identify substances and determine the number of atoms of each element in a chemical formula containing subscripts. So, for example, I gave you the chemical formula for chocolate. You would use that chemical formula to identify the substance, and then you would use that chemical formula to determine the number of atoms of each element we would need to make chocolate. Today you have a 10-question assessment. You can click on the video to watch how to access the test on CMS. Your test code is here below. You'll need to use a periodic table.